Welcome back, everyone. Um, Today we're going to be discussing about logarithms, surds, and indices. Now, this is one of my favorite topics because there are several methods to solve questions based on these topics. And the crux in the CAT examination would be to choose which method or the fastest method for you to arrive at the answer. And how do you come from here to here is how we'll be discussing here. We'll be discussing all the different methods. We'll be seeing a couple of models from previous CAT papers, of course, and we'll solve it in different methods, and then you can be the decision maker as to which is the best method that suits you and your pace, right? Now, before we get into the problems, I'll just give you a quick recap of what these topics hold for us, and I'm sure most of you are familiar with these terms, if not all the formulas. But let's, for the sake of everyone, let's just do it from the beginning. So, I think one formula that most of us would be familiar with is logarithm of x to the power y can be written as y into logarithm of x. So the power becomes your product. This one is something that everyone should be familiar with. And how do you call this? Like, what is the notation for this is? So this is called as logarithm of x to the base a. If base is not mentioned, if they simply say logarithm of x, it means that the base is 10. So this is the default base. But if the base is mentioned, then it is called logarithm of x to the base a. Now, the other properties of logarithms include logarithm of x into y can be written as logarithm of x plus logarithm of y, and vice versa, of course. So if they give you a sum of two logarithms, it can be written in terms of product and vice versa. Now, what is the formula for logarithm of x by y? The same logic holds here. So this can be written as logarithm of x minus logarithm of y. So how do we get this? So it's a straightforward formula, just for the sake of so this can be written as x into 1 by y, right? So the same formula as before, wherein I'm writing x plus logarithm of 1 by y. Now 1 by y can be written as what? 1 by y is basically y to the power minus 1. Now we just discussed that the power comes outside as a product. Therefore, if the power comes outside, it becomes minus. Therefore, this is simply logarithm of x minus logarithm of y. So these two formulas are something which is extremely important along with the power formula. Now, one last formula which you guys should keep in mind is logarithm of x to the base a can be written as logarithm of x divided by logarithm of a. Now, this will be extremely useful, especially in the context of CAT, because uh, most of the problems will be given in terms of base to the power 74 or x to the power 35 or some. Basically, they'll try to confuse you or bombard you with huge numbers to give you an illusion of the difficulty of the problem. But in reality, once you understand these four formulas, what are the four formulas? First one is the power rule. So power comes outside of the product. Next one is the additive rule, which is the addition of two logarithms becomes a product, and vice versa as well. Same with the subtractive rule as well. And then the last one is the separation rule. So you separate logarithm of x by y, logarithm of x to the base a, as logarithm of x divided by logarithm of a. So using these four, you can solve any problem with regards to logarithms. Now, there is another metric, right? So of course there are some obsolete formulas such as log 1 is 0 and log 0 is not defined. So all these are something which you should keep in mind while solving problems. Now, apart from this, with regards to surds, a power m by n can be written as nth root of a power m. Now, how does this work? So if I tell you square root of 4, this is simply 4 to the power 1 by 2, and it is implicitly understood that 2 comes in the square root. The same thing goes for cube root or the fourth root or anything. It becomes 1 by n, so is equal to 4 by 1 by 3 and so on, right? So this formula is something which you should also keep in mind. It's not a formula per se, but an understanding of how methodology works. Same thing goes for this. So a power mn can be written as a power m plus n can be written as a power m into a power n. So this logarithm formula comes from this one itself. So once you know this and a couple of other surds, other formulas become straightforward. So if you know a power m to the power minus m, this can be written as 1 by a power m. So such formulas are something that you should keep in mind, and this topic in particular has a significant weightage. So I think in the last CAT examination you got 6 questions on this. But yeah, so let's deep dive into the problems to understand how we can solve this. So let's do the first one here. Yeah, have a look at this problem, pause the video, solve the question, and then come back to this. Okay, now there are 3 methods to solve this problem. I'll take you through each one of them, and you can decide as to which one is the best one for you. So the first one is to directly take the square of this function and then expand it and then compare. So what we are doing here is there is a rational part plus an irrational part on both the sides, and there's another rational part and an irrational part. So irrational part is this one, and the rational part is this one. So you can compare directly with the rationals and the irrationals. So you can directly equate R1, R2, IR1, IR2, R1 equal to R2 and IR1 equal to IR2. So behind this entire problem lies this base logic. So once you do that, once you understand that, solving this one becomes extremely easy. So let me just expand it and solve it for you. A square plus 3b square plus 2 root 3ab equal to 52 plus 30 root 3. Now if you see, this is your rational part and this is your irrational part. What did I say before? You can compare your rationals and irrationals directly. So once you compare, what do you get? You get a square plus 3b square is equal to 52, and this irrational parts are same, so 2 root 3 is equal to 30 root 3. Sorry, 2 root 3ab equal to 30 root 3. On simplification, you get ab equal to 15 and a square plus, so you get 2 equations and then 2 variables, and these can be solved. But if you observe it here for the sake of the examination, and I think I haven't given the options here, but all the options are single digits. So right, let me give you the options: 7, 8, 9 and 6. So all the options are single digits, right? Okay. Now if you look at the statement here, a and b are natural numbers. So what are the natural numbers that satisfy this one? So before even attempting to solve these two simultaneous equations, you can come up with say 1, 15, 3, 5. These are the only 4 numbers which satisfy a into b equal to 15, which are natural numbers. So the sum of these two is what they are asking. 3 plus 5 is 8. So it's a direct question. Only if there is an option as 16 should you go ahead and solve these two questions. Solve these two equations. If there is not, you can directly take the values of a and b as 3 and 5 and then put them as a plus b equal to 8. Now this is one method. Now there is another method to solve this question, right? So the other method is you take a square root on both sides. Here you expanded the square. Let me take a square root on both sides. So if I take a square root on both sides, what will I get? The square disappears here, and then you get a square root of 50 plus 30 root 3. So this is more of a engineering way of solving this question, if I have to say it, because this is something that people are taught when solving JEE mains or any particular examination. So this entire function should be written in terms of a whole square so that the square and the root get cancelled. So square root of, I'll write it in terms of a whole square into something plus something. So then I can cancel it and then I can directly compare to get the values of a and b. So if you look at this carefully, this is in the form of 2ab, right? It has to be in the form of a square plus b square plus 2ab. So this term has to be in this format for you to write it as a plus b whole square. So this entire term, I'm assuming it to be 2ab term. Therefore, 2 into 15 root 3 is ab. So how can I further simplify this? This can be 5 into 3 into root 3 plus, so a can be either 5 root 3 or 3 root 3. So let us take both. Let us take a is 5. So if a is 5, a square plus b square would be 9 into 3, 27. So this satisfies our assumption that 5 plus 3 root 3 whole square is this. If you expand this, you get 52 plus 30 root 3. Therefore, I can write this value here, which gives you a plus b root 3 equal to square root of 5 plus 3 root 3 whole square. Square and root cancels, so directly you can compare to get your values of a and b. A equal to 5 and b equal to 3, which is the same as before. But again, this is a very tedious process. Unless you are extremely familiar with this method, this will be a slower method to solve. Hence, direct comparison and then substitution with the options is the best method to follow. So as soon as you do that expansion, you get your AB values, and then you check with the options and what are the possible values for A and B, and then basis that you can solve it. So let's move on to the next question. So yeah, we're back to an logarithms question here. Now this should be relatively easy for you guys. Please go ahead and solve it as soon as possible. Okay, so what is the separation rule that I told you? If you guys remember, it is logarithm of a plus b divided by logarithm of 8 whole divided by logarithm of c divided by logarithm of 2 plus log a minus b by log 27 whole divided by log c divided by log 3. Now if you observe, 8 can be written as 2 cube, 27 can be written as 3 cube, and we know the power rule, so the power rule comes outside, so what happens? It becomes 3 into log 2, Here what does it become? Here it becomes 3 into log 3. Now you can cancel the logs and can be further simplified to log a plus b by log c into 3, of course, plus log a minus b by 3 log c equal to 2 by 3. Now let's cancel 3 on both the sides, and then from the separation rule, reverse is also possible, so this can be written as a base as well. So log a plus b to the base c plus log a minus b to the base c is 2, right? So what is the product rule? Product rule is the addition of two logarithms can be a product. So logarithm of a plus b into a minus b to the base c is 2, right? Now they're asking the greatest possible value of a. So before we do that, so let's simplify this further. This can be written as a square. What is a plus b into a minus b? A square minus b square. Logarithm of c is there, right? So the c, if you send it this side, it becomes c square, correct? So this can be further simplified as a square equal to b square plus c square. This is the final equation that you get. Now it is clearly mentioned here that all the three are positive integers, right? And now we have an upper bound on b and c. So if you observe here, b and c should be less than 10. Both can be equal also. Therefore, let us take the maximum value. So since we want the greatest possible value, let us assume b equal to 10 and c is also equal to 10, which gives you what? A square is 200. But they are asking greatest possible integer value of a. Therefore, what is the nearest square root of this one? It should be less than this also, because this is less than or equal to less than or equal to. Therefore, a square is less than or equal to 200. So the nearest possible square root is 196. A square equal to 196, or a equal to 14. For a equal to 14, b and c will obviously be some other real numbers but not integers. But that is fine, because they have been told that it is a positive real number, not necessarily an integer. But a has to be an integer value, and therefore that is the largest possible integer value for this one, a equal to 14. Okay, so say, if you observe here, we used the same four formulas that we've discussed before: the power rule, the additive and subtraction rule, and the separation rule. So basis that, and when to use what is how it matters. So let us solve the next question. Right. So as soon as you see a complex term here, not necessarily complex, but as soon as you see a different term than your normal polynomials, and you know that you have to take a product and solve it as a quadratic equation, you would have to assume that that particular number is some other letter. Let us say t, right? So let us substitute that and check. You get 4t plus 4 divided by t is equals to 81 by 2. On resolving this equation, what do you get? 2t square. So I'm multiplying this 2t here. you get 2t square minus 81t plus 8 is equal to 0. So this is your quadratic equation. Now they're asking sum of all distinct real values of x, right? So they're basically asking the roots of this equation, what are the different values of x, and then they're asking the sum of all those values, right? So before we do that, let us find those values individually. So what are the roots of this equation? You can of course use the determinant formula. If you guys remember, the determinant formula is minus b plus or minus b plus or minus square root of b square minus 4ac by 2a, and then solve for that, or you can simply substitute values and check. So if it is minus, what are the possible values here? The product is 16 and the sum of the roots is 81. Since it will become a tedious process for you to go through that method, if you observe clearly here, 10 power x is t, right? Therefore, if I apply logarithms on both the sides, what will I get? Log of 10x is equal to log t, correct? Yes. Now, if I have already mentioned that if the base is not mentioned, it is assumed to be 10. Now, the power rule, x comes outside. For x into log 10 to the base 10 is equal to log t to the base 10. Now, this value is obviously 1. Therefore, x is log t. Now, you know that this is a quadratic equation, therefore it has two values, t1 and t2. Therefore, it has corresponding x1 and x2. So, what they are asking x1 plus x2 is how much? Sum of all distinct real values of x. Now, x1 plus x2 is what we have to find. Now, what is x1? x1 is log t1, x2 is log t2 is equal to how much? And we know from the product rule that log t1 plus log t2 can be simply written as log t1 into t2. Now, this is simply the product of the roots of this equation. Now, what is the product of the roots of the equation? C by a. What is c by a here? Log 8 by 2, right? So, log 8 by 2 is how much? 4. So, log 4 is your answer. Now, this can be further simplified. This can be written as 2 square, right? Now 2 square, 2 will come outside, 2 into log 2. Of course, the base is always 10. This is your final answer, which is the sum of the distinct real values of x. So let's move on to the next question. To solve this problem, pause the video, try to solve it, and then come back to this one. Here, as soon as you see square roots, and if you see it is in the form of a plus b and a minus b, so this involves some squaring, right? So blindly, without even looking for any shortcuts, let me just square on both the sides. So if I apply whole square on both the sides, what will I get? Whole square on both the sides. What will I get? It will become a square. What is a square here? 6 root 2 to the power 1 by 2 into 2. So it becomes 1, right? Plus, so a square plus b square. B square is again the same thing. Plus or minus. It's minus 2ab. AB is what? 6 root 2 to the power 1 by 2 into x minus 6 root 2 to the power 1 by 2 is equal to 4 into root 2 whole square is 2. So if I do the addition here, this and this gets cancelled. So 2x minus 2 times of, this is a plus b into a minus b, which gives you what? A square minus b square. Therefore, x square minus b square, so 6 square is 36 into 2 whole to the power 1 by 2 is equal to 8. Now let me remove 2 on both the sides, it becomes 4. So x minus of x square minus 72 1 by 2 is 4. So let me do the transpose, send it to the right hand side. It becomes what? X minus 4 is equal to x square minus 72 whole to the power 1 by 2. Let me square it again. You get x square plus 8 minus 8x is equal to x square minus 72. X square get cancelled on both the sides, and then you send the corresponding terms on the single side. You get 8 plus 72 equal to 8x, and x is 10. Everyone got this one, right? So x is your 10 for this particular question. So of course this is done in the span of 2 minutes, but you guys should be much quicker than this, and then apply the squares on both the sides, bring the terms to a single side, and solve it as soon as possible. right? So let's do one last problem for logarithms, and we'll be done for this one. So here it is pretty straightforward. Okay, just have a look through the problem and then observe that the final answer should be in terms of a plus b. They want you to represent this one in terms of a plus b, right? So since they want us to represent in terms of a plus b, let us start with a plus b, right? So what is a plus b? What is a? Logarithm of a into, sorry, logarithm of 30 to the base a, and b. What is b? B is minus log 5 by 3 to the base a. Now we know from our formulas that log a minus log b will be log a by b. So it is log 30 divided by 5 by 3 to the base a. Now how much is this? 6 and then 18. It becomes log 18 to the base a is your a plus b, right? So let us keep this aside. Let us keep this aside. Now you already know that log a, this can be written as log a by log 2 is 1 by 3, correct? Now how can this be written as? This can be written as log 18 by log a, correct, is equal to a plus b. What are they asking? They are asking log a by log 3, right? Now let me substitute log a's value here to get what? Log 18 divided by log a is what? Log 2 divided by 3. So 3 comes here into, sorry, is equal to a plus b. Now how can I write 18? 18 can be written as 3 into log 2 into 3 square, right? 3 into 3 square into 2 is 18 is equal to a plus b, correct? Now if I expand this one, so the product becomes sum, right? So log 2 plus, so log 3 square becomes 2 into log 3 because the power comes outside. Then you do this into 3, of course, is a plus b, and then you divide it individually and you send the other term that side. What do you get? You get 1 plus 2 times of log 3 divided by log 2 is equal to a plus b by 3. So I've sent the 3 that side. Now I'll send the 1 also that side, right? Sorry, yeah, it becomes minus 1, correct? Now log 2 I have it in terms of a. Now I have log 3 also in my final equation. I need log a back. So let me substitute back log 2. From here, what is log 2's value? Log 2 equal to 3 times of log a, correct? Let me substitute that back here. Log 3 divided by log 2. Log 2 is 3 times of log a equal to a plus b minus 3 divided by 3. 3 get cancelled. Therefore, if I just take a reverse of this, I will get log a by log a to the base 3. So log a by log 3 equal to 2 divided by a plus b minus 3. Now this can be written as log a to the base 3. Therefore, this is your final answer. So now that you guys have solved a fair bit of problems on this, I advise you to go and solve back other problems on these same topics using these same 4 formulas. You have your power formula, addition and subtraction formula, and the separation formula. Using this, you can solve any logarithm question. Same goes for your surds as well. And here, where to apply what is the crux. So once you get to know that, any problem becomes easy for you to solve. See you guys in the next video.